All right, number 7. This first equation, I can easily transform to slope-intercept form. Since y doesn't have a number in front of it, a coefficient, all I need to do is move the 2x over. So I'm going to say subtract 2x, and that leaves us with y equals negative 2x and then plus 4, because those will cancel each other out. Okay, so I'm going to graph this one in slope-intercept form. The second equation is in standard form, negative 6x minus 3y equals negative 12. This one would take a little bit more work to get in slope-intercept form, so I'm just going to graph it by finding the intercepts. So I'm going to plug a 0 for my x value, and then I'm also going to plug a 0 for my y value. So 0 for x leaves us with negative 3y equals negative 12. Divide by negative 3. And we get y. Negative divided by negative is positive. 12 divided by 3 is 4. So y is 4. And then we're going to plug a 0 for the y value. That goes away. So we have negative 6x equals negative 12. We are going to divide by negative 6. And that gives us x equals negative divided by negative again is positive. 12 divided by 6 is 2. So I'm going to graph slope-intercept form. I'm going to graph ordered pairs. So I'm going to start at positive 4, line tool, go up to positive 4. My slope is negative 2, so that means I'm going to go down 2 and then right 1. My next one, I'm going to plot these ordered pairs. So I'm going to go to the y-axis and plot 4. I'm going to go to the x-axis and plot positive 2, 0. Okay, now look, it's the same exact line. So this is one of those special case scenarios where you get the same line, which means there are infinitely many solutions, because every point on the line is a solution because they touch everywhere. All right, 8, it says without graphing, we're going to decide, are the graphs of the equations identical lines, are they parallel lines, or do they intersect at a single point? Okay, so in order for me to do that without graphing, I need to write them in slope-intercept form. That's the best way to do that. If I put them in slope-intercept form, I will be able to see if they're the same equation. I will be able to see if they have the same slope, which means they would be parallel, or if they're different, then I know they would intersect at one point. So I'm going to write the first equation, 8x plus y equals 25. To get slope-intercept form, I just need to move the 8x. So I'm going to subtract 8x from both sides. It's going to leave me with y equals negative 8x plus 25. So that's one equation. The next one, I have x plus 3y equals 3. Now looking at these, I can kind of see that these will not be parallel or the same equation, so I think they would intersect at one point, but let's finish it out. We're going to move the x across. And then, let me scoot up a little bit. Bring down 3y equals negative x plus 3. And then to get y by itself, we have to divide by 3. So that leaves us with y equals, now this as a slope is understood to be a 1 in front of here, so we're going to say negative 1 divided by 3x, and then 3 divided by 3 is 1. Okay, so now that they're both in slope-intercept form, I can see they're different equations, so they're not going to be the same line. They have different slopes, so they aren't parallel. So that means that they will intersect at one point.